Here at New Way, we have a flexible rotor experiment that we have here. You've seen there's a shot of its full length, but here we're focusing on this end where we've got a thrust bearing that is supported axially. This thrust runner is supported axially by these two puck bearings. So you've got one of our standard New Way 2-inch bearings on this side and directly opposite one on this side. Now they're plumbed with air pressure that is right now off, so you might be able to hear me make them squeal a little, and you can see that it's not floating freely. Now if I put the air pressure, this is just going to these two bearings, so I'll put that on now. The whole rotor will spin frictionlessly as these bearings actually take this whole structure and bend it out and make themselves a little bit of clearance. So now we also have an air unit that drives a motor up against the shaft. So now this motor's pushed up against the shaft. Go ahead, Paul, let's fire it up. So now the motor is driving it up. Let's go ahead and run it up to about 1500 RPM. So these bearings here are mounted compliantly. They're on Belleville washers. We were measuring the stiffness. You can see these wires are going to proximity probes that are measuring the location of the rotor mounted on a structure that's independent of the bearing housing. He's coming up on about 1400 RPM. So I'm going to disengage the drive unit now. So the motor will back away. So this rotor is now free spinning. And we've got its inertia. It weighs about 400 pounds or so. But we're going to go ahead and just turn off the pressure to these air bearings. There you can see the force on the bearing caused it to pull over, but you can hear the noise. It's making a little bit of dry noise. It's not slowing down quite as fast as it used to, but there, and it's come to a stop. It's not hot. I can still barely turn it. I can't turn it in that direction. But then when I put the air pressure back on, works perfectly. So not only are they good air bearings, they work as a brake.